Hello everyone. Today I'm going to talk about ImageGenerator.py, which is the second part of first exercise of deep learning, Exercise0. So let's start. In the ImageGenerator class, the constructor initializes several important variables. First, we define file paths, label paths, batch size, and image size based on the arguments provided during the object's creation. Next, we set up the optional flag for rotation, mirroring, and shuffle, which allows for data augmentation and randomization during the generation of image batches. To keep track of the current position in the dataset, we use batch index, which is incremented by the batch size every time the next method returns a batch of images. Additionally, we have the underbar current epoch variables, which keeps track of the number of complete passes through the dataset and increases by one after each epoch. We also create a dictionary called classDict, which maps integer class labels to their corresponding class names, making it easier to retrieve class name later. Finally, we use a list comprehension to populate the OR images list with or.npy files found in the file path directory. This list will be used to access the image data when generating batches in the next method. In the next method of the ImageGenerator class, we first check if the batch index is greater than or equal to the length of all images. If the condition is met, it signifies that we have completed one epoch by calling the next method multiple times. In this case, we reset batch index to 0 and increment underbar current epoch by 1. If the shuffle flag is set to true, and batch index is 0, we shuffle the all images list using scikit-learn's shuffle method. At line 37, the batch index is always less than the total number of images, since we reset it to 0 if it becomes equal to or greater than the total number of images. We then create a list called batch images that contains image file names from batch index to batch size. In line 45, we check if the last batch is smaller than the others. If so, we complete the last batch by reusing images from the beginning of the dataset. This ensures that all batches have the same size as required by the problem statement. Batch images contains the image file names, and we obtain the corresponding label for each image file, appending it to the label list. In line 57, we load the image using NumPy's load function. If the received image size does not match the desired image size, we resize the image to the specified dimension, height, width, gender using the resize function in line 58. For mirroring, we utilize the np.fliplr function and randomly decide whether to flip the image using random.choice. For rotation, we use np.rotate90 function and randomly determine the rotation degree k-value using random.choice. Subsequently, we employ the np.expandDims functions to transform the image into a single ND array of size, batch size. We concatenate these images and return the resulting ND array along with the label list. The last line, return finished, is for checking that the batch index has not exceeded the total number of images in the dataset. Current epoch function and class name function were implemented to return the instance variable at current state. In the show method to draw subclass, number of column is the largest prime factor of batch size and number of columns is the other factor. By doing this, we can get a nice looking plot regardless of the batch size. If the batch size is a prime number, the images are plotted in a single row. For example, when the batch size is 7, the images will be arranged in a 1 by 7 grid. If the batch size is not a prime number, the images are plotted in a grid with as many columns as the largest prime factor of the batch size. For example, when the batch size is 10, the images will be arranged in a 2 by 5 grid since the largest prime factor of 10 is 5. So in both cases, prime number or not a prime number, the show method creates a visually appealing grid to display the images along with their labels, making it easier to review the contents of each batches.